Hello and welcome to this LangChain tutorial. So in this video, we'll discuss what are tools in LangChain. So for that, let's start with some limitations of LLMs first. So LLMs are powerful at generating text, reasoning and summarizing, but they have some inherent limitations, which are no real-time web search, first thing. They cannot fetch fresh information beyond their training data. They cannot interact with the web. So now actually if you see many of the LLMs are integrating that web search capability. So with GPT, it integrates with the Bing search. Gemini uses Google search. Anthropic Claude, I think, uses Brave. But there are still many models which are not using this web search capability, or they don't have that web search capability actually, like Meta, Llama, DeepSeek, V4, mostly open source, right? They don't have that capability. Then they don't have API calling ability. So with LLM, you cannot call API directly. So that means no third party or any external system access, right? So that becomes quite a big roadblock if you want your LLM to be integrated with your APIs that in turn may call database or some other services. So all that you can't do with LLM. Then you also can't do any structured computation. So LLMs are not built to do precise math calculation or some database style operations. So that's where they may try to give you approximate answers or query which is not very optimized. So that may happen with the LLMs. And there is no direct integration with workflows. You can't directly integrate LLM with some CRM or Confluence or Zira, right? So that is also one problem with LLMs. Now, for example, let's say you are asking ChatGPT to plan a trip from Bangalore to Jaipur for 5 days with hotel and flight recommendations. That it will do. You will get output like this, right? Flight options, hotel options, not the complete output, but it will give you a lot of information. But then if you ask it, then you book tickets also. That it can't do actually, right? So it will say, I can't directly book tickets or hotels for you. It can give you recommendation, it can give you information about websites, that's all. So that is the limitation I'm talking about. And that is because they cannot directly interact with external systems or services. So these shortcomings of LLMs can be bridged by using tools in LangChain. Tools enables LLMs to fetch live information, perform structured computations, or call API seamlessly. So whatever we saw, right, where LLM lack, that all functionality can be provided by tools. So behind the scenes, actually, tools are just functions. So if you are using Python, you will write a function with well-defined inputs and outputs. That means it will have some parameters and a return type, right, which it will return. Then the LLM actually decide when to call them and what arguments to pass based on the flow of the conversation. This decision process is known as tool calling. So we'll come to that later. What actually is tool calling? First, let's try to understand what is tool. So this tool calling will happen when the model detects that a user's request can't be answered with text alone and instead requires an external function. Then it will send a tool call that I need to call this tool, right? So in order to understand how to create tools, first we have to understand types of tools in LangChain. So there are actually built-in tools and custom tools. So built-in tools, as the name itself suggests, are provided by LangChain itself. So LangChain itself provides lots of pre-configured tools which cover many scenarios. So you have for search, you have for API calling, you have for DB tasks. You can get the complete list from documentation in LangChain, how many tools are available. So some of them we'll see here. with example. So you have request tool for API call. So you have request get tool, request post tool, and for other REST API also you have for put, patch, delete. Then you have Wikipedia query run tool. To connect to Wikipedia, you have various search tools like DuckDuckGo search to get search results through DuckDuckGo. You have Google search and many other actually. There is also Python REPL tool that is used for doing some complex calculations. So there are many such built-in tools. Let's try to see example. First, let's try to create a DuckDuckGo search. Okay, so I created a folder here, L11 tools. In that I'll create. So let's say I have a let me clear out. DuckDuckGo demo. All right. So you can get the required tool from LangChain underscore community dot tools. So from there, I'm getting the DuckDuckGo search run tool. Then you can create an instance of this. So DuckDuckGo search run. So when you create an instance of any tool, right? So by default, every tool in LangChain is a runnable object. That means you can use invoke method and pass the parameters as a dictionary, or if you have single, then you can just pass it directly. So using that information, what we can do is, since it's a runnable, so I can call invoke list 5 main sports events of 2026. Let's say this is my search, and then I print L11 within that DuckDuckGo demo. Okay, so I've got my tool from DuckDuckGo search run. Okay, it needs a Python package pdgs, so that is missing. That means first I should run pip install requirements.txt. Now let's try to run. So I got some result. So even though I'm saying 26, it is starting from 25, which may have gone through till 26. So that is one. Then we have UEFA Championship League. All right, so it has given me some result. I'm not sure whether these are actually major events or not. But yeah, I've got a result. That's what I wanted to show, how you can use DuckDuckGo search tool. Then we also have another tool, which is request get tool. Request tool demo. So I'll show you request get tool where I'll use a fake API JSON placeholder, which is a free fake API which you can use for testing. So these are the imports, request get tool, and you also need JSON request wrapper, which will wrap your response as JSON. So I'll get my response as JSON by using that. I can create a instance of this also, request wrapper equal to JSON request wrapper. Then I can create of this request get tool where I can pass this information. So that will take requests wrapper one parameter, which I can pass as requests wrapper itself. And it also takes one more parameter, since we are integrating with third-party JSON placeholder. So I can just say allow underscore dangerous underscore requests equal to true, which is by default false. Now we can invoke it. Tool.invoke. So we have to make a call. Let me get that URL. So I'm making a call to JSON placeholder. In that there are post resource that I'm calling, limiting the result to only 2. That I can print. All right. Let's try to run this one. Oh, sorry. So I got 2 results from the URL which I'm calling. So this is the API request. So I got 2 results as JSON. So we'll create one more tool. We'll use one more built-in tool actually, not create a tool, which is Wikipedia tool. So for that, I'll create a Wikipedia tool demo. So for that, imports are, you'll get the tool, which is Wikipedia query run tool. And you also get from utilities Wikipedia API wrapper. So this is actually a wrapper which calls the Wikipedia API. So this is actually the main thing here. That wrapper in turn you'll wrap within the Wikipedia query run tool to make it a tool. So first thing we have to create an instance of this API wrapper. So let's name it API underscore wrapper equal to Wikipedia API wrapper. Here I can give how many results I need. So let's say I need first 3 results. So top underscore a underscore results equal to 3. I want to limit, let's say, character also, which I get doc underscore content chars underscore max. So for each page which is fetched from Wikipedia, get only the first 1000 characters. That's what I'm telling with this parameter. Doc underscore content underscore chars underscore max. Once you have this API wrapper, that's what you can wrap within this tool. So Wikipedia query run, there you takes this parameter only, which I pass as named parameter, and this will be my tool. Then I can invoke it. So results equal to this wiki underscore tool dot invoke. Let's search for LangChain. So then I can say print results. And to run it, you'll also need Wikipedia package. I already have that from retrievers chapter. So if you don't have, you need to install it. Then only you can run it. And to run it, I'll need to call L11 tools within that wiki. So it gives me 3 pages, LangChain, then another one, and another one. Okay, so these are example of some of the built-in tools. Now we'll try to create our own tool and run it. So you can create your own tool also, a custom tool to encapsulate your own specific business logic. Now there are 2 ways in LangChain create a tool. You can create a function with @tool decorator, or by subclassing base tool class, which is the base class for all the tools. So there are two ways. So first we'll see using @tool decorator, which is the simplest way to create a tool. So let's create a simple example where we create a multiply tool. For that, let me create a new file, multiply multiply tool demo dot. So for that, you need to import the tool itself, which you'll decorate. Then you can create a def multiply function, which you can decorate with tool. So decorator, you provide some metadata with this decorator. So here it is telling that this function is going to be a tool. So it will take two parameters. Let's say both are float, and it will return a float also. All right. So that is my function where I'll just do a return with a into b, right? And you should also give a doc string. So let me hit that also. Used to multiply two numbers. Okay, so this function is used to multiply two numbers. So now I have a tool ready. Just by using this decorator, your function is now a tool. That means it is a runnable. So I can call invoke method on it. So multiply dot invoke. Here we have two values to pass. So I can use a dictionary. I can pass value for A, let's say 5, and value for B, say 7, and result equal to this. Then I can just print this result. I'll come to explaining it properly. First, let's run it. So looks fine, right? We have everything. So if I run it, multiply, right? So I get result as 35, 5 into 7. So it is working fine. Now just to explain the things we have used here. So first thing is using tool decorator that makes your function a tool. That is one thing. And every tool is a runnable. That is why we can use invoke method on our tool. So these two things I hope are clear. Another thing is you should provide your function parameter better. I mean, it is not required or mandatory, but it is better to give type hints that these two parameters of type float and this function returns a float value. So all these type hints you should provide. That will help LLM to decide which tool actually will do the work which is required. So we are not yet integrating it with LLM, but LLM will send a tool call. Okay, call this tool for this work. So to decide which tool to call, it needs all this information that will help it in deciding which tool will get the job done. So you should provide these parameters with types that will help LLM in deciding, okay, what all values it should pass, of what type, what to expect as return value. Then another thing is you should also provide a doc string, which is descriptive enough to tell what it is supposed to do. So you should give some context also for your LLM that this tool does this job. So if you need this kind of task to be done, call this tool. All right, so this is very important, type hints as well as this doc string. Another thing is by default tool name comes from the function name itself. That is why we can use multiply here itself. If you want to give another name, then you can give it here like this, double quotes, any other name. multiply underscore tool, then this will become the name of this tool. Okay, for now let's stick to this function name itself. So that is our tool which we have created, a simple one. One more thing is, once you create a tool, it will have some metadata which you can access also. Actually, let me put it here itself. So print result, after that I'll for metadata. So you have name, which gives the name of the tool. Then you have description, which will actually give this doc string. Then you have arguments, args, which will give you the arguments, input schema that is required. So input schema itself will also give you the full schema object. And this doc underscore underscore doc, that will also give you the doc string. So it is same as the description. So I'll run again. Okay, so if you need any information about the tool, you can use all these metadata functions to get that information. So these attributes will give you the information. So tool name is multiply, description, what you have given here, that is the description. Arguments, if you see A and B, which is type is number. Input schema will give us Pydantic model, and document string is given as tool that can operate on any number of inputs. All right, so that is the metadata you can get about the tool. You can also use Pydantic schema in tools that will give it some information about what all to expect and of what type. So that is also there. With tool, you can pass your input as Pydantic or JSON schema. So any of these you can use. And that you will pass using args underscore schema parameter in tools. Okay, so using that you will pass the model that is used. So with that, benefits, as I was telling, ensures that argument passed to the tool match the expected types, and you will have strict validation. All right, so suppose I want to create a tool that passes the person information. Right, so we are just creating a simple example, but you may have API where you go to the database, get some person information. So we'll create a simple version of that where I can create that as a schema. So I'll just create that whole example. So here I'll create a file, schema. Let's say input schema tool dot py. So suppose, as I said, I want to create with this person schema. So that's how I can define a person which extends base model. That is how you can create a Pydantic schema. So there is a name which is string. You can give some description also using field. Address, which is also string. Address underscore type, which can take one of these three values: home, office, or other. Okay, so this is type of address. And age, which is int. So these four fields it should have. Now if when I create a tool, I can give as arg schema. So that becomes my input schema. Okay, so whenever I pass it some information, it will check that it matches the schema or not. So then I create a person object out of it and send that as a JSON. So using this function, I can pass it as a JSON, model underscore dump underscore JSON. Now I invoke it with some information here: name, address, address type, and age, and printing that result. So if I run it, um, input schema tool.py. Input should be home office or other because I've given as resident. So that is the benefit you get because I've specifically given it as literal that it should be one of these value, home office or other. Here I'm giving resident, which is not one of these values. So I'm getting an error. So that is the benefit. Now if I change it to home, right, or let home, then I get my person object back as a JSON because that's what it is written. All right. So if you have a complex schema, that's what you can do. You can create a Pydantic or JSON schema also you can use. So here we are creating a Pydantic model and using that here as args underscore schema. So you can use schemas also with your tool. Here we used directly because it was a simple one. But if you have some complex type, then better to go with the predefined schema. All right, so that is about getting the schema with tool. So now let's go to the other way of creating a tool, which is by using the BaseTool class. All tools in LangChain actually inherit from the abstract class BaseTool. So if you want to create a custom tool, you can also do the same. You can inherit from the BaseTool class. So when you are subclassing BaseTool class, then your class also should have following attributes and methods. It should have a name, a unique name for the tool, description for that tool, right? How you are going to use a tool. Then ask schema. If you have some schema, right, that you can give as we gave with at the rate tool, right? Same way here also you can give. Then your logic of the tool that will be in underscore run method, and same logic you can also have in asynchronous implementation, right? Underscore a run. So same logic as asynchronous implementation that also you can do. So these are the attributes and methods which you should have in the class, which inherits from the base tool class. So let's try to create a base tool using the same multiply example. So let me create a file multiply base tool. Okay. So what I need here is these are the imports base tool. I'm also going to create a input schema using Pydantic model. So I've got base model and field and type to define the type. Now first thing I'll create a model, Pydantic model, so that will inherit from base model. So class multiply args, I can name it. Here I will have to give the type. So I'll have one a will be of type float, right? So a as float, and I can also give some description. So field, within that I can give the description. So I want it to be required. So for that, what you can do is you can use three dots or ellipses, which tells that this is a required parameter description. First number to multiply. Same thing now I can do again. Just call it P, float field second number to multiply. This is my Pydantic model. Now I'll create a class which will be my tool. So multiply, which extends this base tool. Right. So that's how I can create a tool by inheriting from base tool. So what all we need to give here, first thing, name. So let's say it is a multiply tool. Then what do you need? A description. Which is again str equal to used to multiply two numbers. So this will be a description. Then I can have args underscore schema where I can get this Pydantic model which I've created. So args underscore schema for this type will be, that's where I will use this type base model. It will be of base model type and multiply args, right? So now I have used the first three. Then I have to use def underscore run. That's where I'll write the logic. So here I can say float b float returns float return a into b, and I should give a doc string also. Then I can create, should be in this. Then I can do one thing, sync one float a sync version of multiplying two numbers, right? That's what I can say. But this, let's say it is not yet ready. One thing I am missing. Let me first finish this one. So I can raise not implemented error, a sync version not supported. Okay, so one thing is, since these are now class methods, not independent function, first parameter should be self and self in both, right? So float and raise not implemented error. Now I can create a tool instance, apply tool. This time it is a class, so I create like this. An instance of multiply class, this class. Now I have my tool instance. Rest of the things are same, so I can now use invoke on this because it is a runnable where I can pass as a dictionary a value, say 6, b value, let's say 8, and print result. Then I can run it 11 in that multiply base tool. Okay, dot py. So I get result as 48. So that is another way you can create a tool by extending the base tool class. So generally you will use at the tool decorator only, which is mostly used for quick, simple tool creation. If you need a very complex, highly customized tool, then you can go with base tool class. As a class, you can create with the inheritance and all the methods here itself. Right, async version also you need all that. If you need, then you can go with the this base tool. Otherwise, for simple one, you can just rely on @tool decorator. Okay, so now we have seen both the ways of creating a tool. Though one thing what we have not done is integrating this tool with LLM. That actually is the way you will run these tool, not directly invoke this tool yourself. But first, let's try to understand how actually LLM sees these tools which you create. So when you decorate a function with @tool or you create it using base tool, whatever way you choose, LangChain will wrap it into a runnable object that I've been telling you. That is why you are able to use invoke method. And it also exposes the metadata that the LLM can read. So that also we have seen what all metadata is associated with each tool, your name, description, arguments, everything. So that all is sent to the LLM so it can read. So tool name, description, argument schema, all that we have seen also how what all metadata is there with the tool. So LLM does not actually read your Python code, which if you think right, it's a good from security point of view, right? That in the code you may have credentials, API access keys, and many other sensitive information which you don't want LLM to see or send to the LLM. So it won't see your code as such. It will get this information only, some metadata about that, and your tool is exposed as a runnable. These two things will happen. What it sees is the description and argument schema. So when it sees some task or within a user request, right, it sees some task for which it thinks your tool can do that work based on the information it has, it will wrap the tool's name, description, and input schema and send that information back as a tool call wrapped in an AI message. So that also we have seen many times. What you send is a human message object, what is sent back from the LLM, that is the AI message. So within that AI message, it will send a tool call with all this information that this tool should be called, that you get by name with some description and the arguments required to run it. Okay, so that is how it will run that tool. So we'll see that in the next video actually in tool calling in LangChain. For now, I'm just telling you that is what will happen when you want to run a tool. Coming to the last topic in this video, you can also create a toolkit in LangChain. So you can bundle related tools actually to use together for a specific task as a kit. So you can create a toolkit with many tools bundled together within that to do one specific task, right? So you can also create a toolkit, and there are many inbuilt toolkits also. Biggest advantage of toolkit is that it can be reused across different agents or workflows because you create it as a toolkit, you just need to get it in that particular agent. So there are many inbuilt toolkits also, like there is a Gmail toolkit, there is GitHub toolkit, there is SQL database toolkit. So that will group together all the tools. So in Gmail toolkit, you may have tools to send a mail, read a mail, classify mail. In GitHub toolkit, there are tools to get the pull request, see the files which are there, it will list all the code files. So many tools are there, different tool to do related work, right? All the work related to GitHub. Same way you have SQL database toolkit, which contains the tools related to SQL jobs. So you can, it has query SQL database tool, which can query the database, right? Gets SQL query as input, output is a result from the database. You have info SQL database tool, which will give you the schema, right? List SQL database tool, so it will give you all the table names within SQL database. Query SQL checker tool, which can check the query whether it is correct or not. So it bundles all these tools which are related to SQL task. Same way you can create your own custom toolkit also. So for that, what you need to do is you have to define individual tools. So you can create functions, right, with the red tool to define individual tools. Then you have to create a class which inherits from base toolkit. And in that you should have a get tools method where you pass the list of all the available tools in that particular toolkit. So that is what you need to do. Okay, let's try to create one. So in the tools itself, let's say toolkit demo.py. So let me get some of the things. So import is tool. This is the base tool which you also get from the same LangChain.tools, and base toolkit which is LangChain underscore core dot tools. So this is what you'll use, right, to create your own class. So these are the two tools now. Multiply, we are already using one more tool which is quite simple, only self-explanatory. Now what I want to do is I want to create a toolkit which will include these two tools, right? So let's create a class. You have to create a class which will extend this base toolkit. That is the first thing. In that you have to create a method get tools self that will return you the list of these tools, list of base tool. So you give base tool as a type here, which is the parent of all the tools. Now what you need to do is I can return these two tools here, right, which are multiply and add. So by default name is same, so multiply and add. That's it. My toolkit is ready, which bundles these two tools. Now I can use it by creating an instance of this class, my toolkit. Then I can call this method to get all the tools. Tools equal to toolkit dot get underscore tools. Now I have all the tools of this class. Let me get to that. It is a big one. Then if you want to go through all the tools and print metadata, that's how I can do. For tool in tools, I can get the name, description, args, input schema, doc. So this all is metadata. Then I invoke each tool also with parameters. So both have same, so I can do that. Otherwise, you may have some if else also. If you need this tool, then pass these parameters. Here it is same, so I can pass them directly. And result of invoking tool.name result. So that will give me result for first multiply, then for add, right? Because I'm calling both of them. Toolkit demo. So tool name, it gives first multiply arguments and 15, 5 into 3. Then, okay, there's only one tool. Where is that? Okay, it is there, right? Tool name add, description add two numbers, 5 plus 3, 8. So both it is able to run, right? So that's how you can create a toolkit. So if you have related tools, rather than writing all the information or all the logic in one tool itself, you can break it into separate tools, right, doing the specific task. Then you can create a toolkit by bundling all of them together. Thanks for watching the video. Please don't forget to like and subscribe.